Hello, my name is Niels Drønen. I'm from the coastal department at DHI. The coast is vulnerable to forces from the sea. Coastal protection and maintenance is an ongoing challenge. Waves and currents stir up the sediment from the seabed, and the suspended material is moved in the flow direction. This is what we call sediment transport. One of the most important types of sediment transport is the longshore transport, which occurs when waves approach the coast with an angle and break close to shore. It may be hard to tell standing on the beach, but looking at the coast at a distance, we recognize that the shoreline is changing position from year to year. This is due to longshore transport picking up and settling out sediments in different patterns along the coast. This molding and erosion of the coast by the waves and the currents is what we call coastal morphology. It poses a huge problem for coastal engineering projects and for coastal community. Historical attempts to prevent erosion is by adding coastal structures. But whenever a construction is put on the coast, it will tend to block the natural sediment transport. Sand will be held back on one side, but on the other side the sand will be missing, and increased erosion is now a problem there. The overall erosion cannot be stopped by hard structures. Positive effects are in most cases only temporary or local, and in reality the erosion problem is just exported downstream. Another important way of dealing with erosion is by using sand nourishment. If we artificially add sand to the coast at the same pace as the coast is being eroded, we have a very simple way of neutralizing the erosion. The sand will be eroded, so new sand has to be added to the coast periodically, say once a year, to keep up with the erosion. One might compare this with painting a house to protect the house against the sun and the rain. Structures are sometimes needed, and we need to develop a design for the sand to pass around it in the best possible way. This is most efficiently done by using computer models to simulate the sand movement for different layouts. And from these results, decide on which one has the desired effect. Computer models can be used to simulate the behavior at the actual coastal area, using information about wind and waves, depth conditions, and sediment types in that area. It's a very important tool for predicting impacts on the coast due to anticipated climate change and to study mitigation measures. At DHI, we expect an increased need for coastal protection, maintenance, and coastal development in the future. Therefore, we have a clear focus on developing computer models that support design, decision making, and developing and sharing knowledge on coastal morphology.